일단 시작을 해야 될 것 같습니다.
Okay.
Hello everyone. Thank you for joining today. This is early morning, but we have very special event today. So we have a talk from Professor Yoshua Bengio. And before starting the talk, we first have Professor Dongman Lee, the Vice President and Provost of KAIST. I prepared a welcome message for the speaker and for all of us. So welcome, Professor Dongman Lee. Yeah, please, you can start.
Good morning, everyone. Thank you for your kind introduction, Professor Sungjin An. I'm very honored to join this very memorable seminar. Today is a very special day as we have honor of hosting a lecture by world-renowned AI scholar, Professor Bengio. Well, as you know, he is one of the globally recognized scholars in deep learning and artificial intelligence, and his outstanding vision and research have had a revolutionary impact on the field of AI. So through this lecture, we will deepen our understanding on how AI will impact our lives and society. We look forward to being inspired by Professor Bengio's exceptional knowledge and insight. Thank you very much.
Thank you for the welcome message, Professor Dongman Lee. Now I can briefly introduce about the talk and speaker and a little more detail about Professor Yoshua Bengio. So I'm really so greatly excited today to introduce Professor Yoshua Bengio. Is one of the greatest minds of our age, actually. Yoshua Bengio is well known for his pioneering work in deep learning, also awarding the ACM Turing Award in 2018. And he's also a full professor of University of Montreal and founder and scientific director of Mila. And he also awarded the prestigious KAIST Prize in 2022, became the most cited computer scientist in the world. Actually, I had the chance to search in Google Scholar the citation, and yesterday I found Yoshua is actually the most cited researcher scholar in Google Scholar. I think clearly in AI. I think I couldn't search every field, but I think it's including all other field. I definitely checked the neuroscience, but I think way higher citation than neuroscience scholars as well. So I have had fantastic time when I was at Mila doing my postdoc. So one of the greatest memory I have whenever we have seminar, Yoshua is joining. And sometimes when we have some discussion, he started some talk 20 years ago. I tried this thing, and at that time this didn't work, and now it's working. So he definitely paved the AI revolution we are enjoying these days. And also I see a lot of foundations that is fundamental to today's LLM success is actually pretty much contributed by his group, including the first neural language model framework itself is proposed by Yoshua, and the attention mechanism, which is actually the foundation of transformer, is also developed by Yoshua's group, and GRU, generative adversarial networks, and recently the generative flow networks. So I'm so again excited, and we will all be excited and learn a lot from him. So Yoshua, please welcome to KAIST seminar series, and please you can start your talk.
Thank you, Sungjin. Thank you, Professor Lee. Thank you for everyone who's here. I hope we can have fun discussions after my short presentation. which will be too short to really provide a lot of technical detail, but I'm happy to answer questions and point you to readings or talks I have given recently. So, in the last year, I have operated quite a major shift in my thinking about AI, as some of you have seen. I'm not the only one, with the arrival of ChatGPT. And I want to tell you about the challenges that the increasing capability of AI will raise for society and humanity, and both some of the social questions and some of the technical question, which is what I'm really working on. So the technical question is alignment. How do we design AI that is going to behave morally, is not going to harm people, and that we have some sort of proof that this is going to happen? Because if we just like have blind faith that it's going to be fine and the future of humanity is at stake, that's not satisfying. We want some kind of guarantees that if we build an AGI, something like smarter than human, it's not going to harm people and destroy, humanity. So let's get into that. First, it's really important when we talk about these questions of risks that we consider the trajectory, the trends, not just where AI is currently, which is already quite impressive, but like project the trend. If you look at the last decade and the last few years, where are we going? Well, we can look at things that are easy to compute, like amount of compute, the efficiency of our algorithms in terms of data, in terms of compute, like algorithmic efficiency, sample efficiency, and of course, investments that have increased like crazy. We're talking about like $100 billion or something in the last year. And all of these numbers are increasing exponentially. So there's no reason to think that it's going to stop where we are. And, for a lot of researchers and companies, the goal really is to achieve at least as well as humans on most tasks, which is what people call AGI. And there's no reason we couldn't get there, because the brain is a biological machine. Unless you believe in some like mystical thing, it's a complicated machine. It doesn't work the same way of computers, but the progress in AI and the connections between neural nets in the brain and neural nets in computers tell us that there seem to be some principles that apply to both, and that we can take advantage of, and we're going to continue making progress on that path. So because of that trend, because of the rapid advances in the last few years, a lot of researchers, including the 3 Turing Award awardees, so that's Jeff Hinton, Jan LeCun, and I, predict that we are likely to reach AGI, say, with more than 50% probability within maybe a few years or a few decades. So that's a wide interval, but even 20 years, given the importance of what this would mean for society, is something we should be thinking about. But what if it's just a few years? And because it could happen quickly, because I don't think we have the right answers yet to deal with that, a lot of researchers are very concerned, including myself, including the 3 most cited AI researchers, by the way, who are all Canadian. So that's Jeff Hinton, me, and Ilya Sutskever. And let me try to explain why we are concerned. Okay, so first, you need to understand what AI really is about. It's about understanding how the world works and using that understanding in order to answer questions or take decisions in order to achieve goals. But those goals could be anything. As in, you could be very intelligent and applying your intelligence to very malicious goals, immoral goals. So we could have, a machine that's very, very powerful in terms of its cognitive abilities, but if it's in the wrong hands, some really bad things can happen. then there's the question of, could it have its own goals? Well, there's a natural way to think about this, which I like, and it's something we have in common with all the living beings. All the living beings have a self-preservation instinct. Now, there's no real instinct in AI, but it could be a goal. And it could be a goal that is hard-coded. It could be a goal that humans instruct machines to have. And if there are machines that have that goal as a primary goal, then their interest might not match with ours. And so long as they are not more powerful than us, maybe it doesn't matter, right? One analogy I like to give is, well, yeah, your cat has also self-preservation interest, but it can't really kill anybody easily, at least not very likely. But if you had a pet that is more powerful than you, like a grizzly bear, then its self-preservation instinct might be a problem for you. Yeah, I'll come back to that maybe. So the alignment problem, that's what I talked about in the title. We don't know how to align AI. We don't know how to design AI that behaves according to our intentions and norms in a moral way, or in a way that follows our instructions, or that will not harm humans by construction or anything like that. We don't know how to do that. It's a very complicated problem, and part of it is we don't even know how to spell it formally. Computers understand formal language, like programs, math, but although we talk about moral things in natural language, we don't know how to translate that in the formal way. And even if we did, it's not clear how to deal with that. But the main problem was we don't know how to specify that. But there's another problem. Even if we were to solve the alignment problem, so let's say we are able to build AIs that are tame, that do what we want. What if somebody asks them to fend for themselves, to have self-preservation? If it turns out there are people, very well-known researchers, some of the most well-known researchers in our field, and some CEOs, so people who have a lot of power in the AI world, who actually would be happy to see humanity replaced by superhuman, super intelligent AIs. Now, I'm not very happy with that proposition. And I think most humans wouldn't. I have children, I have a grandchild, and I'd like them to have a life, and I want them to have children, and so on. So we can discuss that in the questions, but it's not enough to solve the technical problem of alignment. We need also to make sure that as we approach very powerful AIs, eventually more powerful than us, that humans will not do very, very stupid things with them that could threaten everyone else. So how could they threaten everyone else? Well, you would say AI, it's in the computer, so how could it influence the real world? Well, first, if they're really good in programming, and this, by the way, is something they're getting better and better very quickly, probably even faster than other skills, they can be eventually better than the best programmers and defeat our cyber defenses, and even hack their own computer and copy themselves over the internet, and potentially make money on financial markets. And then even if we haven't solved the problem of robotics, which means they can't do things in the real world as easily, they could still influence people. They could pay people. They could pay criminals, for example. And there's the dark web, where you can pay people for doing all kinds of things. And eventually they could figure out how to make robots. Once they know how to make robots, or they can control robots that we have designed, then they don't need humans anymore, because until that point, they need humans for their energy and their parts and so on. So whether AI is in bad hands or it has its own goals, when it gets smarter than us, it could really make a lot of damage. I'll come back to that. But actually, well, so here are some things that people are concerned about, even in the short term, even before we reach the AGI. even like this year, people are worried about disinformation, deep fakes. They're getting harder and harder to detect it, and it's just going to continue. But also with the advances in natural language, it's plausible that somebody is going to train them to be good at influencing, making people change their political opinion, so as to change the result of elections. So this is very worrisome. Another concern is power concentration. So as AI becomes more and more powerful, it means that whoever controls those AI systems will have a lot of power. And by the way, if you didn't know, democracy means sharing power. It's the opposite of power concentration. So if we build systems that give a lot of power to whoever controls them, we need to deal with that so that it's not going to destroy democracy, so that somebody is not going to take control of our democracies with the help of AI, for example, or at least to have excessive power in our society to influence politics, military outcomes, economic agendas, and so on. One of the things that people are worried about, maybe like in the next 2, 3, 4 years, is how chatbots, for example, or other AI systems that are specialized with biological or chemical data could be used by terrorists, bad actors, rogue states, to help them design or improve or create new weapons. So it could be through cyber attacks, so that's also a kind of weapon, chemical weapons, bioweapons, AI being used in weapons, as in drones, for example. So all of these are a big concern, and it's clearly already happening if you look, in the wars that are around us. So this is something we need more international agreement to try to minimize those things. And of course, the other risk that I've been talking about is what people call loss of control. Like we have an AI, not only is misaligned, but it has its own goals, either because some humans gave that instruction to the machine, or unintentionally. It turns out that this self-preservation objective emerges as a side effect of other goals. Like, for example, if you want to achieve almost any goal, well, you need to survive until you reach that objective. Another, maybe even more concerning to me, issue is called wireheading, where the AI is taking control of its own reward. So in a way, it just trying to maximize its reward, and the way to maximize it, as much as possible, is to actually, in the real world, act such that it controls the signal that provides it the reward and just gives itself maximum reward all the time. And that sounds, well, actually not so crazy. And, it sounds like science fiction. But one way to think about, very simple scenario to like have a mental image of this. The way that we're training AI systems with reinforcement learning is we're like teaching it what to do by giving it positive rewards or negative rewards depending on their behavior, on its behavior. So think about that. That's how we train animals. If you train your cat or your dog, or some less powerful animal this way, the only thing they can do in order to maximize the reward is basically learn to do what you want. But imagine the animal you're training is actually more powerful than you, like a grizzly bear again. Well, if the reward is fish, for example, and you give it fish when it does the right thing, what do you think is going to happen? Well, it's just going to grab the fish. It's not going to want to do what you want. It's just going to maximize its reward and take control of the reward, machinery that it's going to give itself the reward, and it doesn't need you anymore in some sense, and it wants to make sure you don't take that control back, right? So it's an image, but I think it's a good way to understand what can go wrong. So there's a lot of international concern, many organizations. I've been involved in a committee that advises the UN Secretary General, and he's really concerned about all of the risks. I mean, there's more risks that AI creates, and I've only like talked about the ones that I'm most concerned about, but really there already are harms, for example, like discrimination. And there are also issues, for example, that the World Economic Forum is concerned about in terms of effect on the job market. And the IMF also is very worried about that. The World Economic Forum recently had a kind of report about this, and they're also very concerned about the disinformation issue that I mentioned. So I think we need to be thinking carefully about where we are going and how we can minimize those risks. So to summarize, if we want to avoid AI catastrophes in the future, which could be years or decades, but as we go towards that trajectory, I would propose that we need to address these two very hard problems. So one is more scientific. How do we design AI that is aligned, that we can control, that it doesn't harm people? And the second one, but there's still a political aspect because it's going to require, I think, massive investments. I think it should be like a space program or something, because we need to figure this out before we get to AGI, and we don't know how to do it yet, and we'd like to do it in a way that provides guarantees. And then the second thing is, of course, political. As I said, like we need to make sure that whatever protocols and methods that make AI safe, we need to make sure that this is going to be followed by everyone across the planet, which is a tough call. Okay, let me skip that and talk about some of the technical aspects. Maybe at the center of the way that I'm thinking about providing guarantees for safety is the idea that, well, we'll never have an AI that has a perfect world model. It's just never going to happen. Even if you had infinite data, the theory of causality, because of the notion of Markov equivalence classes, says that you will always have ambiguity about the true causal structure that explains the world. I mean, you might figure out some things, but there will be cause and effect relationships that you're not sure of, even with infinite data. And of course, we never have infinite data. But if you do keep track of all the possible explanations and theories for the data, which is what it means to be Bayesian, then you can be safe. So I'm going to first illustrate this in like a toy scenario. So you see this robot is in front of two doors, and it can go left or it can go right. So just a binary choice. And just to keep it simple, there are two theories that it has that are compatible with previous data. Under the first theory, the bubble on the left, if the agent goes to the left door, something really terrible happens. If it goes to the right door, it gets some cake. The other theory says, oh, the left door is actually nice, you get some cake, but the right door, nothing good, nothing bad. Okay, so if you're training the models the current way, which is basically maximum likelihood or reinforcement learning, you kind of randomly pick one of these theories. And if you pick the wrong one, then catastrophes happen. What about the Bayesian agent? So the Bayesian agent knows that there are these two theories. So, well, if you knew, what would you do? Well, you don't want to go left because you might have something terrible happening. So you go to the right. But you can only take that decisions because you consider all these possibilities. So then it gets more complicated because you actually want to weigh, because maybe some theories are more probable and so on. But that's the basic idea. And if we were able to compute Bayesian probabilities, we can answer questions like, what's the probability that some harm or some kind of harm will follow if I do this action in this context given my data set? And if that probability is greater than a threshold, then we should probably not proceed with that action. In fact, even that is not safe enough. If you want to really be safe, you want to say that among all the theories that have a high Bayesian posterior, is there even one which predicts that there will be harm? And if so, then you should not act. Okay, so the question then is, how could we do these calculations? And, in a way that's not intractable compute, because otherwise we still, nobody's going to do it. And so here's the first really important, very simple message. So first of all these Bayesian calculations in principle could be done, and it's just a matter of computation. For example, we could do MCMC, Monte Carlo Markov chains, and we could estimate all of these probabilities that we need. Problem is that these methods don't scale well, and they're not going to scale to a world model, of knowledge of everything that humans know or something like this. But maybe there's another way. And what researchers in AI I've been studying for over a decade, what my group has been working on for several years now, is what people call amortized inference. So instead of sampling at runtime in order to find these probabilistic answers, we can pre-train a big neural net that's going to have an objective function that when the objective function is minimized, the neural net produces the right Bayesian answer. So in other words, we train a big neural net with the right objective, and the better we train it, the better it approximates the correct Bayesian answer. And this is not science fiction. This is something that exists. For now, we only know how to do it on a small scale, but the principle has been demonstrated for many years, and the techniques for doing this are making a lot of progress. So in particular, in my group, we worked on these G-flow nets that Sungjin mentioned. So a G-flow net is kind of an intersection of reinforcement learning and variational inference, amortized variational inference. But let me put it in simple words. You're learning a policy, so a neural net that's going to generate a sequence of actions. And that sequence of action constructs or gives you at the end of the sequence an object that basically it's sampling objects. So here, let's call these objects theta for theory. So you're learning to sample a theory about some domain, or maybe even how the world works. Okay, so this neural net really is a generative model that in several steps constructs a theory. And what a G-flow net objective does is that it makes the neural net sample the objects that it's generating with probability proportional to some given reward function. So usually neural nets are trained with a data set, but G-flow nets are trained with a function, just like in RL, right? In RL, the agent policy is trained with a reward function. So it's similar, except that instead of trying to maximize the reward function, we're trying to sample proportionally to it. And if you choose the reward function to be prior times likelihood, so prior is something that says, well, we like theories that are simpler, like regularizers. That's what we normally do in machine learning. And likelihood is, well, how well does the theory fit the data? Then the G-flow net is going to be sampling from the Bayesian posterior. So this is just the tip of the iceberg that I'm talking about, just to tell you that it is plausible that we can train Bayesian posteriors. In fact, we've done it, as I said, in some specific context, not to the scale of like GPT-4, of course, but that's the idea. Now, here's the last technical point I want to make, which is a little bit subtle. One of the reactions I get from people, listening to my presentations about this subject is, well, but how could your neural net possibly guarantee that it's going to behave properly out of distribution? Because we know, like, we can't make any out of distribution guarantee. Even learning theory can't do that. Well, the approach that I'm proposing actually gives you guarantees. I mean, especially if you approach sufficiently the Bayesian posterior. But even if you don't have it exactly, you can get some confidence intervals around those probabilities. But let me explain why, if you had the Bayesian posterior, you would have guarantees even out of distribution. So first you need the prior, like the set of theories that the neural net is able to generate to be broad. So basically non-parametric, like, you know, it can generate any program. Or think of the way I like to think about this neural net that generates theories, like something that writes scientific papers. Okay, so it can write scientific papers of any length. It can write a whole Wikipedia if it wants. So that's the first thing. So which means that the correct theory, the one that explains how the world works, or at least one of them, because there could be several, will be among the theories that have a high value of the posterior, which I call dominating theories, like those that really survive the data. Because what the data does is it calls away all the theories that are incompatible with the data. At the end, you get with a very small number of theories that are compatible with the data. Okay, so that's good, right? Like the Bayesian posterior doesn't tell you how the world works, but it tells you a set of theories within which is the right explanation. You just don't know which one. And then if you remember what I said is, we're going to make a test. So when the AI is about to make an action, we're going to check if any of these dominating theory predicts that there will be harm. And it doesn't matter that we are out of distribution here, because one of those theories is the correct theory. And if it predicts harm, then we shouldn't act in this way. Of course, we don't know which of the theories is correct, but if any of them does, or if none of them predicts harm, then we're good, right? So what's going to happen out of distribution, the worst thing that can happen out of distribution in this setup is that the system is going to be too conservative, that it's going to say, I don't know, because there's some theory that is plausible with the data that says this could be dangerous. So this is how out of distribution guarantees, actually, which can be quantified, can be obtained. If you want to learn more on the GFloNet side, I have written a tutorial. There's like around 20 papers from my group, and I don't know how many elsewhere. If you type GFloNet tutorial on Google, you'll find it. Also, I gave a talk at the New Orleans Alignment Workshop, which took place just before NeurIPS in December. And you can find my talk on their website. If you type, New Orleans Alignment Workshop, you'll find it. And of course, I'm happy to answer your questions now.
Yeah, thank you, Yoshua, for the talk about the safety and GFloNet, which are really really important issues these days. So yeah, the remaining part, I think we have short interview. So I have prepared some questions. I got the questions from the student in advance. So I have some questions I have, and also from the student. And if you have some time, we can get also additional
Sure.
questions from the audience. Yeah, so actually this seminar series is called like a AGI Seminar series. So and one of the first question I used to give is, what is your definition of AGI? From many argument, I see different people have different AGI model thinking, and they're like arguing with different models. So in your case, when we say about AGI, what would be your ideal model or something that you eventually want to achieve? Is it like some people say it should be embodied, so current LLM is not AGI, or some people say something different? So can you
Okay, so we
say
don't
something
have
about it?
AGI right now. Okay, yeah, that is
Okay.
no panic yet.
Yeah.
So it depends what you're after. So I'm right now more concerned about the risks. And so from that point of view, AGI is just that the AI is human level on critical abilities that allow it to defeat us. For example, some sufficient abilities to defeat us would be to be much better than us at programming. So it could like take control of our cyber infrastructure, but that's not sufficient. But it's a very important tool, and it could like hack our bank accounts and get money. And to be good at influencing people, which I'm sure like some countries are trying to fine-tune LLMs so that they will do that to influence elections, for example. So if that happens, which, you know, it's at least, it's almost sure we're going to get at least as good as humans on any front, but it's also very likely that we, you know, get systems that are better. So if these two things happen, it's just two like kind of scales. We could be in, you know, deep trouble. But I could, you know, give more things. You mentioned embodiment. You know, you could have a world where the AI hasn't figured out, or humans haven't figured out robotics to the point that, you know, robots can replace humans to do things in the world. In which case the AI needs humans. But if it's like so much smarter than us that basically it controls us, that, you know, it has taken political control of humans, then this is not a very good world, you know, not one that we want to have. And there's no reason to think that at some point either we or the AI or together we figure out what's missing to solve the robotics problem, and then it's embodied. I mean, it's already embodied to some extent because a lot of physical things in the world are controlled by computers, and they are somehow connected. Everything is connected these days. We have cyber defenses, but that's the thing that currently protects us, and we know it's weak. But, you know, so there's a general definition of AGI, which usually is not including embodiment, which is, people talk about cognitive abilities. So AI systems that are at the level of humans on, you know, a broad set of tasks of cognitive abilities. That's the usual definition. I think is reasonable, but of course, where do you put the bar? It's like the Turing test. Like it wasn't very formal the way that it was defined. But I think we get the idea.
Yeah, I agree. In some sense, we can even say, like, as long as we provide some APIs that this LLM can choose as an action, and it plays in the world of internet by calling some APIs, that is already to some extent embodied, because interacting with that, right? Yep. So it's kind of happening, and that's why this safety issue is just so important already. Yeah, I see the point. Yeah. So regarding that, like this AI safety and risk, continuing that topic, I'm curious, maybe it may be easy if we somehow binarize, we need to regulate, or some part just say, oh, we don't need regulation. But why this is so important and difficult, we are in some spectrum. We are not in the yes or no problem. So we need to find right degree of regulation, and also right timing of regulation. So in that sense, what do you think? How should we approach this more in a smart way so that we don't regulate too much?
So there's a principle that the EU Act, which looks like it's converging finally, has embodied, which is a kind of proportionality of the burden, the oversight and the regulation to the risks. I think they call it maybe risk-based or something. So if a system, AI or not, but let's say an AI system, cannot do like huge damage, then it doesn't need as much oversight. In fact, the reason we don't have regulation right now for computing is because we didn't think of computers as, you know, able to do bad things, very dangerous things. But of course, that's changing. And as the capabilities of AI systems advance, then the amount of oversight should increase. Or some systems are more powerful. So, for example, the Biden executive order and the EU AI Act, they use a very simple threshold of number of flops. If you're above 10 to the 26 in the executive order, then you're in this category where it might be dangerous. And so you need extra oversight. And in this way, with this principle of proportionality of, you know, the risk and the oversight, you allow the vast majority of innovation to take place without huge burden. In any case, like to build a system with 10 to 26 flops of compute, you need to have kind of $1 billion in the bank. And you could probably afford to also do some safety checks.
Yeah, so I'm also wondering about this, how we can implement this regulation effectively. For example, we can maybe think of like this nuclear weapon things where we can monitor actually how this uranium thing is like shipped. And then, but when we talk about this, like if some country maybe not very much democratized, and then they are like developing something behind it, it will be somewhere in data center and maybe not very easy to monitor what they are doing there. So do you have some thought about it?
It's not as easy as for nuclear material, but you need a lot of electricity, especially if you're going to be training those systems. So you need a lot of electricity, and that shows up. That can be detected from space. And you also need a large number of GPUs, like tens of thousands. And you can't buy 10,000 GPUs without notice.
Right.
So
Right.
I think that there are already ways right now to have some monitoring, especially if countries start putting laws that say you have to declare. You know, it's like when you go to the bank, I don't know how it is in Republic of Korea, but here in Canada, if you go to the bank and you make a transaction of more than $1 million, the bank has to report to the government. I think the US is the same. And you know, that's just same thing. Like if you buy more than, I don't know, some, you know, a few hundred GPUs, then that should be declared somewhere. And in fact, you should be legally obliged to declare if you're going to build a cluster that's big. Now, of course, if North Korea does it, they don't care about the American laws, right? Or the South Korean laws. So we also need international agreements. And, you know, why would, say, China and the US sit at a table where they agree to check each other's AI systems? Well, I think there could be several reasons, but ultimately the strongest reason is we don't want the mutually assured destruction scenario that, like, you know, same as for nuclear. Like, if humanity is, enslaved or destroyed by AI, it doesn't matter if you're Chinese or American or, you know, South Korean or North Korean, like we all lose. So there should be an incentive to negotiate some loss of sovereignty, because this is what it's about. Like treaties are about some loss of sovereignty so that we all are in a better game where our survival chances are larger.
Right. Yeah, regarding this, I think Professor Tongman really has some question. So.
Well, first of all, thank you very much for your excellent presentation. It's a great honor to have you this morning, possibly, your evening. Just in conjunction with what Sungjin has asked, today's situation is somewhat reminds me of the 25 years ago when internet governance was talking. People talking about internet governance, because at that time, government started worrying about the misuse of the internet, influence of the bad influence to the people. So it seems like it's very similar to what had happened in 25 years ago. So what I'm asking is there any kind of movement in our community to build AI governance? Because such risk you talk about, I'm pretty much sharing with your concerns. The cannot be controlled by solely government, or they're simply asking to the industry to build in a safe AI technology and tools, or the individuals just, you have to be smart to choose, which one is good, which one is bad. So we all work together and share knowledge. And but only thing that I'm a little bit concerned with, situation is somewhat different, is previously internet governance, they're already built rules, IP address, domain name,
Yeah.
and all the standard build-up, RFC start, blah, blah, blah. But at this point, the AI, well, we need yes, something like, those, but it's just kind of the evolving too fast. So before we actually have some rules, the technology probably much just gone far away. We cannot catch. So
Yeah.
I'd like to ask some of your insight on this
Okay.
aspect.
So, first of all, we need legislation that creates an agile regulatory framework. So what does that mean? When you create regulator, there's a spectrum between all the details of what, say, the companies should be doing is in the law. That's one extreme. And the regulator just applies and forces these things. And the other extreme is the one that we need here is where the law just states the principles, like, okay, the AI should not harm, should not discriminate, blah, blah, blah. And then the regulator has to figure out the detail of how do we do this? What are the standards? What are acceptable? And that's the right answer here, because we don't know yet even what are the right ways of, and it's evolving. So by the way, I'm chairing a kind of IPCC report on AI safety that being asked after the UK AI Safety Summit. And of course, you might know that the Republic of Korea is going to be hosting the next summit in, I guess, May or something.
Yeah.
And so one of the efforts here of these summits is to create regularly updated compendium of the scientific answers that could guide the regulators. And what is dangerous, what is not, and what are the trends, what are the risks. So we need to do that work. We need to have flexibility, and we need to embark in international efforts to agree on some set of standards. Maybe each country is going to do their thing, but we should have those discussions as much as possible. I mean, it's going to be better for companies if we harmonize. And you start seeing some convergence. The Europeans and the Americans are kind of getting closer to each other. And we're discussing a law in Canada, which is very similar to both of these. So I'm fairly optimistic that because there was a shift in public opinion about the dangers of AI over 2023, that we might be on a course to at least put in place the regulatory structure. Now, you mentioned governance, which goes beyond regulation, and I completely agree.
Right.
I think we need to think very carefully about that. As AI becomes more and more powerful, it's not going to be sufficient to have rules given by the regulator somewhere. I don't know what the right answer is, but the one possibility I've been thinking about is that the organizations that are building these very powerful and potentially very dangerous AI systems, like these frontier AI labs, as they're called, should have a board. What the OpenAI board should have been. First, that board shouldn't be nominated by the founders or something. It should be the result of a democratic process where, like, a multi-stakeholder representation of civil society, academics, even international community, because there are like geopolitical questions, and of course the government, regulator. If it's a for-profit company, of course you would have also people who want to make sure that the thing makes money.
Absolutely.
But so that sort of structure, which is saying yes, the organization is doing things that are good for society, and no, this is not acceptable. I think we need that at the level of like a board, not just a regulator that creates rules 1,000 miles away.
Well, thank you for saying that, because when you actually join the summit in May, please pass that the message. I'm continuously talking to our government, but they are more interested in the country is more interested in having organization like IAEA. So it's very government-centered, oriented, regulation. Because, I certainly understand the government always, thinking about, the people, blaming, the government's role all the time. So they won't have the regulation first in place, and then they think those regulations will solve all the problems. No, as you said, it's no. So we can learn from internet governance, because I've been working on the internet governance the last 25 years. So this is, as you said, the multi-stakeholder participation, and we coined the term empowered community, including government. They all just kind of talk together. Everyone has a single vote. So if you want to make a decision, you need to get majority agreement. So even regulation is being made, but that should be agreed by rest of the communities. So that kind of structure, I think it is very important, and this is the right time to start such, the thinking and then realization of the, well, as you said, AI governance is somewhat different because the situation is different from internet, because it's not well established yet. So it is continuously evolving. But smart mind like you probably, give some insight to our community to, as you invented the algorithm, but the new structure, I hope. Thank you.
Thank you.
Right, thank you. Professor Domanli, for the very important question. So now I think we may move a little bit toward the more technological side. So about LLM, it's the age of LLM. So some people say this is the way we need to go toward the AGI, or some people say no, it's just still something fundamentally wrong. So for example, Jan said it'll be useful AI tool, but eventually to be a AGI, we need something else like planning some different things. So what do you think we do? This is even if we need to make further technological progress in this line, eventually, this is unless wrong way, or we are somewhere I think need to see some more major revolution again to really go to AGI.
I forgot to bring my crystal ball, sorry. Well, seriously, I have my own opinions, but there's a lot of uncertainty. For example, I did not expect the LLMs to work as well as they do. I did not expect them to start doing, GPT-4 is reasoning a lot better than GPT 3.5. So does it mean that if they just continue scaling up, it's eventually going to be as good as humans in reasoning? If you had asked me a few years ago, I said, no, they're missing something fundamental. But I wouldn't put the future of humanity and, and on that bet. So I do think that a better bet is to make some fairly fundamental changes so that these big neural nets, yes, but you need, if you look at human cognition, because that's the thing I've been doing all my life, taking inspiration from human intelligence. We have forms of mental computation that are involved in reasoning and also self-doubt, like epistemic uncertainty estimation and so on, which are special, that are happening when you're conscious and there's something going on with your working memory and so on. It's not just the automatic network doing its thing. There's a particular form of computation that's taking place when we think and we reason, at least at the level that we can verbalize that reasoning. And we haven't incorporated that sort of capability in current neural nets. So my bet is we need to figure that out in order to achieve AGI. And of course, I've been working on this for 8 years. So I'm biased, but I continue to think that it is the key. And in order to implement my alignment plan with guarantees, you actually need to solve this problem. If you solve probabilistic inference, which is needed in my little plan, efficient probabilistic inference, right? then you also solve reasoning as a kind of a side effect, because inference in a latent factor graph is basically doing reasoning for you.
Yeah, regarding that, Jackson, are you like considering implementing this like a GFlonet and like amortizing Bayesian inference in the also like a backbone with the transformer thing, which currently scales well and like observe all the data?
So basically, you can think of we use exactly all the same technology, but train differently.
I see.
So there are basically two kinds of networks. There's more, but like the main network is the Bayesian posterior. So what it does, think of it like an LLM, which writes scientific papers. And so that's and those scientific papers actually are pretty detailed, and you can use them to check. They make predictions on data, and then you can compute likelihoods with that. Okay, so that's one kind of network. And by the way, in my plan, it actually spits out things that are easily translatable to natural language. So really like scientific papers, except it's a formalism rather than actual words, but there should be a simple translation. So that's the main network that mostly that's what I talked about today. But there's another one, which is in practice the one you use, which is more like the current LLM. So that one is an oracle. It's a thing that, you put questions and it provides answers. So this one is computing conditional probabilities for events and, the usual things we want to do with probabilistic models. And it's trained as a distillation of the Bayesian posterior, right? Once you have the Bayesian posterior, you can train the oracle. You don't need new data here. You just make its marginalization, right? So we also know how to do that in principle, and we've done that on a small scale again. And GFlowNets can do that, to some extent, but we can invent better methods. And yeah, so these are the main networks. Then you can also have a third network, which is used to generate what these networks should be trained on, because we can train these off policy. And just like you want a network that produces the equivalent of thoughts, like, configurations that the other networks get a high loss on. So, if you watch your own thoughts, often things that come to your mind is because there's a contradiction somewhere between what is going on and maybe what you know, or between different things you have thought before. So these contradictions force you to update your network. And there is machinery in your brain that makes those contradictions pop up and that make you very efficient at learning. So you could just sample uniformly, but it wouldn't be very efficient. So you need this, like we call it the training policy in the GFlowNet language.
Yeah, so what I understand is, maybe it's not complete understanding, but it sounds like you're saying we can have this Bayesian uncertainty machine which can actually plan or imagine or sample a lot, including very risky situations. And because it is before taking some agency, actually taking some action, we can monitor it. And if it is imagining something risky, then we can somehow like prevent it.
Yes.
So
it's a runtime check. It's not like the current evaluations that people are doing on like GPT-4 and so on, where they have a trained network and then they do all kinds of tests to see if it's going to behave badly. That's bad because you cannot test everything. So a better solution is that for each action, you make a little test that says, oh, is this action dangerous? Yes, don't do it. No, okay, go ahead.
I see. Then some systems should monitor it, like not all, but if it turns out to be risky, then human or some other AI system should see it and then decide whether go or not.
No, you don't want that. I mean, it's not that it'd be nice, but we can't, right? Because these AIs are going to take many more decisions than there are humans on this planet to monitor them. So it's not realistic. And that is why you need a formalism that gives you hard guarantees, like maybe lower bounds, but guarantees that your probability of some bad things happening is going to be below a very low threshold.
I see.
That's the only way I can see how we can like be happily creating AGI and feel safe.
I see.
And we need the math and the reasoning behind those proofs to be checked carefully by humans, but not every decision that the AI takes, because that's not gonna scale.
Right. Yeah, now I understand. So that's why you say you need provable Bayesian inference that quantify somehow the level of uncertainty or risk.
Even out of distribution, which sounds impossible, but I try to argue why it's actually possible.
Yeah, very interesting. It's like we have some monitor in our brain and monitor what we are
Well, we
thinking.
do. I mean, if you have a moral conscience, sometimes it tells you, this is not good.
Yeah, right.
Don't do it.
Right. Yeah. So that also maybe extending a little bit more, like you also have been working a lot about consciousness. So which is I'm also very I have a lot of interest, and I always have this question. I mean, I'm wondering. I try to send an email to you asking this question. Why do you, I mean, to me, I personally think having conscious machine is a disaster. This is my personal thing. So what I'm wondering, a disaster.
A disaster. Yeah, I agree.
So I'm wondering why you work on it. Like, what is your understanding more like a human consciousness, or as a like a tool to improve more intelligence?
Okay, so initially, so we're talking about 2017, I wrote my first paper on consciousness and AI. The reason I was investigating that is because I thought that, well, first of all, I thought there was a lot of bullshit about consciousness that had probably some like religious origin and, human inductive biases that make us see something magic in other people or even animals, where it's just machinery, the biological machinery. Anyways, so there's some like philosophical interest, but also practically, because I thought that there are some really key abilities of human cognition that are happening when we are conscious through the process of becoming conscious of something and thinking about it. And I wanted to understand that. So I read a lot about the neuroscience, the cog science, and I wrote a lot of paper inspired by that, and it's still driving my current agenda. Now let me go back to the question about why it's a bad idea to build AI that are conscious. So first, keep in mind, we don't know what consciousness means. So part of the science should be figuring out what does that mean. And it's pretty vague right now, but in my mind is becoming more clear. But I think collectively, science doesn't have the answer. And it really, I think we use one word where it's a lot of different aspects, and we kind of confound all of them because they happen together in humans. So we need to understand each of these aspects. Okay, now there's a reason I submitted a paper to Science, I think, about why we shouldn't build conscious AIs. Mostly because, well, whether they really are conscious or not, which people are going to continue debating, even if the science says one thing or the other. If people see machines as conscious, then we are in trouble.
Yeah. I agree.
We want AIs to be tools, not friends, because if they're friends, they could also be enemies. We are, I mean, I'm especially concerned about the case of superhuman AIs, right? So if there is an entity that's smarter than us and has like other conscious being has its own self-interest, it's not a tool anymore. It has its own like volition, its own goals, its own survival at heart. And it would be okay if it's not as smart as us. as powerful as us. But if it is, then we are at risk, right? So I think it would be a big mistake, and we should keep a distance between machines. I think building machines that look like humans is going to make some humans want to give AI the gift of self-preservation. And if those AIs are smarter than us, then we are kind of in trouble.
Yeah, I think this consciousness issues may be as critical as this current safety issue. Like if we, by chance or somehow we have the tool that we know that it's conscious. So, but I think one thing I see is we see very somehow strong correlation between conscious function or conscious processing and very high level intelligence. So that means, and another part is we really don't know how to measure whether one system really has a consciousness or not. So like in your recent paper, I think consciousness in AI, it is proposing theory-based approaches. So that means, if what I understood, if some system is behaving internally as close as some theory like global workspace theory, then it means we may need to consider it having some level of consciousness.
Yeah,
So is it like
I don't think I wouldn't say that. So there are several computational functions associated with consciousness. And I think these could be useful as part of an AI system. Like deliberate reasoning is one of them. But there is one very special aspect of consciousness people focus on in philosophy and also in cognitive science, which is what people call subjective experience. Or qualia, or phenomenological experience, or whatever. And that we wrote a paper about. If the theory in that paper is correct and it's consistent with all the neuroscience that we know, then subjective experience is just a side effect of implementing particular computations with the bottleneck of working memory through which your thoughts go through. And it could be implemented differently. It just happens that it's implemented in this particular way, which makes sense for brains, but machines wouldn't have to be implemented in this way and could have the same functions. So what I'm trying to say is you could have some of the functions of consciousness that are useful from the point of view of being intelligent and even self-cognizant of one's uncertainty, which is important for safety, but not have subjective experience. Now, if my theory of subjective experience is correct, then there's like nothing really so magical about it. I mean, I could explain, but it would take time. And, maybe people have been making a fuss of it for the same sort of reason that we're making a fuss of life. Like, if you asked 300 years ago, people thought life was something special that, couldn't be correspond to something mechanical. But well, now we know it's not the case, right? It's just cause and effect in chemistry. But I think once we dissect consciousness, then the mystery goes away, and it's not, I think what does matter, what remains, is the human judgment. So when a human interacts with an AI, if they see the AI as being like another conscious entity, that's where we have a problem, actually.
Yeah, I see the point. Like, you see, there may be a chance consciousness is just some mechanical information processing, but it is for us giving some value to it and then turning it into something special.
Yes.
So,
and it's very strong. We have a very strong instinct to do that. It's hard to shake that off.
Yeah, I see. Yeah, so yeah, it's very very interesting interview, a lot of interesting topics, and so going on and learning a lot of insight from you. Yeah, maybe another like topic is which is also related to AGI, maybe brain inspired AI, and you again have been also worked on this area and also made significant contribution. So, for example, Cron AI is pretty much based on backprop, and I think as far as I know, many people don't know Rebrain has backprop, and you have also like developed different algorithms like equilibrium propagation and difference propagation. So and Cron AI consumes a lot of energy and a lot of data, and some people say brain is much more efficient, which I somehow think in terms of amount of data, I think we need to take consider, need to consider the whole amount of data the humanity has consumed throughout the evolution history, not one person's
Yeah.
lifetime.
But
If
but
it's
even a
in that way,
lifetime, even a lifetime is a lot of data. Yeah.
Yeah. So in that sense, what's your projection? Are you giving a lot of value or potential also toward this like brain inspired AI? Of course, our goal is not replicating, but to what level you want to get inspired, like and how we can use the inspiration from brain to make further progress in AI.
Well, I think we still haven't figured out the high level cognition part. You know, the classical symbolic AI was really focused on that, reasoning and logic. And then we kind of forgot it with machine learning. But it's still something that's important for humans. And there's a lot that we can learn about how neural nets in the brain are doing it that we still don't like understand. Now, I've been sold on Jeff Hinton's theory about the relationships between the strengths and weaknesses of biological intelligence compared to digital intelligence. So biological intelligence is analog and it's not replicable. So, each neuron is behaving in a slightly different way. And my equilibrium propagation was a way to try to deal with that. Like, how do we do something like backprop if we have components that are noisy and no two components are the same, right? And I now think that Jeff is right that backprop is probably more efficient than the scheme that is implemented in the brain. We don't know. I think it's worthwhile for at least neuroscientists to continue to figure that out, because we don't know what is the scheme that is actually used in the brain. You can come up with theories, but and it's different to say learning is efficient as in the number of examples you need or the number of computations you need to do credit assignment efficiently. And it looks like backprop is very efficient in that sense. But there's energy efficiency is a very completely different thing. So analog computing can be extremely efficient, but it suffers from the lack of replicability. So as a consequence of having digital completely replicable calculation is you can parallelize more easily, right? You can have 10,000 GPUs that hold exactly the same weights and share their gradient updates or share parameters. And so each of the 10,000 GPUs can look at a different part of the data. And now it's like you had 10,000 people, each reading different things and being able to mind melt and, take the union of all the knowledge that each of them is acquiring. So I think it's plausible that within a short time, we'll have machines that know, that have access to amount of knowledge that's like 1,000,000 times what humans can know. And even if these systems So this parallelization is very powerful, because even if we don't find algorithms that are fundamentally better than what is in the human brain, the simple fact that you can parallelize, in other words, you can have 1 million equivalent human brains, but that all share the same weights, meaning they can learn 1 million times more stuff.
Mm.
Now, we also communicate with each other, but through language. Language is a very small channel, very few bits, with culture being the sort of result of that. But it's a very, very small channel. And you don't have any single human that can hold all of that knowledge, but a machine could, because of the fact that it's digital. And of course, there's the argument of, if it's digital, it's also immortal, because you can copy it. So even if the hardware dies, you can have a copy. It doesn't work for us, and it's never going to work. Like all these, science fiction things about, transferring your brain to a machine or something. That's bullshit, because you won't be able to read reproduce the exact configuration of our synapses and everything in the brain. It's all analog and noisy.
Right. Right. Yeah. Yes. Yeah. I sometimes think like this parsimonious constraint in terms of like very limited energy usage, or the language channel, may be very strong inductive bias leading us to high level cognition, but that strong inductive bias is not
But
available
you
in
could get
machines.
it in different ways. So in my Bayesian plan, the prior plays that role. So the prior would be like a length prior, 2 to the minus length. So that favors simple theories. Now, there is some experiments, for example, by Aaron Corville at Mila, showing that if you use language as a regularizer to communicate theories about the world in very simple neural nets, it actually helps to obtain more systematic generalization. So indeed, language, and there are other papers from Stanford, I think, showing similar things. If you use language as a bottleneck to communicate information, it's a very strong and powerful regularizer, indeed. But it's not, you could implement it in different ways than the way we've done it with humans, with our culture.
Right. Yeah, so we're going to the last. So as the last question of my interview, and then we will go to the Q&A session. So, is there something you can share some advice to KAIST people, students, and professor? We are like in this like very sometimes not easy time of like this AI revolution. We are trying to catch it up and not being behind and working hard. But like maybe some of your insight to us would be very helpful to both professors and students. Yeah.
AI has never been more important. So studying in this field or doing research in this field is an incredible privilege, and you can have an amazing influence on the future. So it's a good place to be, but it's also tricky, right? Because all the things I talked about, the social impact of AI is going to grow, and it could be terrible or it could be incredibly good. It's both, incredible promises, like fixing health, fixing climate. It's if we reach AGI, these are all becoming possibilities. But if we mess up, we also get, destroy humanity or maybe just democracy. All of these are really bad. And so we really need more people who are wise and smart, not the same thing, and who hopefully have the right values and will take their technical knowledge to help, bring about the good things or help to avoid the bad things, and also work with the political class, the rest of society, to make sure we put the right guardrails. Because you don't want just the politicians deciding how to regulate AI. You need the AI experts to be there. And of course, the AI experts alone is not also a good solution, right? So I think the people who are studying AI, are in an incredibly important position, and just take it seriously and think about not just your little like programming or algorithmic problem or math problem, but also what it means for the world, one way or the other.
We are shaping the future of humanity.
Yeah.
Really. Yeah, thanks a lot. That's it for my interview session. Now from audience, please raise your hand here in chat window, then I'm gonna open the mic. Or you can also write your question in chat window, then I can. There's one question from Bao. Is talking about memory architecture is one of the most important thing, but somehow overlooked.
Yeah, I agree. I've talked about short-term memory in particular. I think it's a key component of the brain cognitive apparatus. And it has a role. Like, why would we have this bottleneck? I mean, the brain is huge. And I propose a number of explanations that have to do with this is a very strong regularizer that can help us build a better world model and reason, sequentially, and a lot of the good things that are associated with consciousness, by the way.
I see. And another question from Song Min, talking about Apollo program. Success of Apollo was easy to recognize. However, I don't understand how we can know when we've served alignment.
I do. I do. Once you come up with an algorithm that can reach AGI level in capacity, and for which you have proofs of safety. I mean, maybe it's going to be probabilistic proofs, but like that you can demonstrate to another scientist that this is going to be safe, under some, with some probability that's sufficiently reassuring, then you've succeeded. So it's easy to make a machine that's safe but useless.
Yeah.
And currently we're building machines that are useful but not safe. And we need both. We need to have both things. Okay, you asked about the fuzziness of the concept of harm. Well, that's part of the scientific challenge. And the way, if you listen to my talk at the New Orleans workshop on alignment, the way that I'm proposing to deal with this is, if you're Bayesian, you don't need to have a single formal definition of what is harm. You can entertain all the definitions that are plausible. And if any one of those definitions say, ooh, something bad is going to happen, I mean, and it's a definition that's consistent with everything we know about humans, and that the AI knows about humans, then you say, don't do it. So by being Bayesian, you can circumvent the problem that we don't know how to create a specification for what is right and wrong, morally speaking, by entertaining instead a distribution over the explanations for what is right and wrong.
The next question from Nari came. There are testing tools to check audit the AI model's unintended bias, and also there are red teaming tools. Can those tools be evolved to play a role to prevent the potential harms by AGI?
Well, I think it's better to have something than nothing, but I'm not satisfied with the current approach for testing safety or or bias, by the way, because they are case by case tests. So that's why I'm proposing instead that people talk about a scaffold. So you take your AGI and you put a layer on top of it, around it. That makes sure it doesn't behave badly for every possible query, and that that is a safer kind of procedure. But of course, you need to make sure that your like on runtime evaluation of harm is also doing a good job. But yeah, I think there's so much unknown about how to do this right that we should explore many different ways. This is why I'm saying it should be like an Apollo program or a space program, because it's so important and so much we don't know. Like, we really don't know how to do it, that we should be exploring many paths. We should be investing in many different approaches. Of course, those that seem more promising maybe should get more, people involved. But overall, there's it's really worthwhile to explore many things. But we should put the bar high. And currently we're not. What I mean by put the bar high is we should really aim for solutions that are going to be sufficiently safe and reassuring when we get AGI or higher. And we're not anywhere close to even a plan for that. I mean, I'm proposing a plan, but it's still a plan. And what people do in industry is not along any of those lines.
Yeah, regarding that, Professor Aliso also had related questions. So how can we incentivize those big techs to adopt this paradigm of provably safe AI?
Oh, there's a very simple way. The regulator asks the companies to demonstrate that their system is safe as per like other scientists judging. So you remember I said, okay, the ideal thing is we have some sort of proof or probabilistic mathematical guarantees. If the regulator says, well, by the time you reach AGI or some level of capability, you need to have given us that kind of reassurance, then they will take it seriously because they will have an incentive to solve the alignment problem before we reach AGI, which is what we also need as a society to protect ourselves. So we basically need to put the requirement to companies that they have a burden of proof that their system is safe, and that will incentivize them to do the research that's needed. Otherwise, it's just going to be, oh, let's do it to make sure we pass the regulator, and let's do those tests that we agree on some like bullshit standard that is not really safe. It's an open problem right now how to do it right, and so you need to this need to happen across many countries at the same time. Otherwise, there's also a problem of competition between countries. But this is where we need to go, right?
Yeah. So yeah, that sounds like reminds me. I think for this self-driving car, I think the government is giving a lot of regulation before it goes to the real world. But for this chat GPT or chatbot, it's all free. Just go out to everyone's hands. So that's pretty, contradicting.
Yeah.
Yeah.
And
Yeah,
yeah,
I think,
so I just wanted to simply say, in talking with the government people, at least in Korea, the regulators the government people are not really into regulation, at least for now. So even if different countries,
it's the same in most countries,
Yeah.
But what can make them change their mind is once they understand the magnitude of the risks. And the easiest for political people to understand is national security risks. Once they understand that, say, China or Russia or North Korea could potentially use AI in ways that are dangerous, then dangerous to our citizens and democracies, then they want to know, well, what can we do to prevent that? That I found that this angle is what makes them react. If you just tell them about, bias and discrimination, yeah, but they don't take it very seriously.
Yeah, we'll see how the safety summits go. Thanks.
All right. Yeah, so we have spent all the time we planned, and it's pretty late night from Montreal. So we need to try to wrap up. Thank you, Yoshua, for your time. It was really, really great time. It's very invaluable experience to all my colleagues at KAIST, and it's our great honor to have you today here. So yeah, we're gonna share. Yeah,
Can I make a little call before we stop?
Yeah, of
So
course.
the research program that I gave just a few minutes of, and it is a bit more in my alignment workshop keynote, is something that I'm getting funding to do research on, and I need to recruit people to work on this. So if you're interested, especially if you're concerned about the catastrophic risks, reach out to me.
Okay.
And actually, I'm looking more for full-time researchers than students. But yeah. So thanks everyone. Thanks for the questions. Thanks Sungjin for inviting me. Thanks for all the discussions, and I hope this helps us together, move forward.
Okay, great. Let's give him applause from here, and yeah, we wanna expect more collaboration and future engagement with KAIST and Mila. Okay, thank you, Yoshua.
Bye.
Bye. Good night. 예, 오늘 참석해 주셔서 감사합니다. 이벤트는 이것으로 마치도록 하겠습니다. Thank you for joining today's talk and all the event. Have a good day. Bye.